Alright, in this topic we shall talk about eddy currents. We have seen it before in the previous topic of this chapter that when a magnetic flux which is linking with the coil is changing, then an induced current will be set up in the coil. So that induced current can be produced not only just in a conducting coil, but it can also be set up in a solid metal. Okay, all right. So when a solid metal like this one is exposed to a changing magnetic field, okay, once again, when this solid metal is exposed to a changing magnetic field, then what happened? Because of changing magnetic field, then the magnetic flux that is linking with this solid metal will change. So because of the changing magnetic flux, then current also will be induced in this case. And this current, which is induced in the solid of a metal, is known as eddy currents. Why do we call eddy current? Okay, eddy means like a circulating part, or I can say like a whirlpool in water. So these currents which are induced in the solid of a metal, they are, you know, forming a circular part. So that is why this current induced in the solid of a metal, it is known as eddy current. This eddy current was first discovered by Foucault in 1895. So that is why this eddy current, it is sometimes known as Foucault current. Okay, all right. So if you remember from Lenz's law, this Lenz's law, it is actually tells you about the directions of the current induced in the coil. According to Lenz's law, the current induced in the coil will flow in such a direction so as to oppose the cause that produces the current. So similarly here, if this is a metallic body, and the current, if it is induced in this metallic body, then this current which is induced in this metallic body will flow in such a direction so as to oppose the motion, right, of the cause that produces this induced current. Okay, all right. So in the year 1895, Foucault, he demonstrated many experiments to explain about the presence of eddy currents in a metallic body. The first experiments that he demonstrated, it consists of a pendulum bob, in which the bob of, in this case, it is like in the form of a copper sheet, right, like a metal sheet. And this metal sheet he took like a copper. Okay, now this copper sheet behave like a pendulum bob of the pendulum, and we know a pendulum always oscillate in this way. Okay, so when there is no magnetic field which is passing through this pendulum bob, then this copper sheet, it is free to oscillate, and it keeps on oscillating like this, okay, without end. But as you can see, we have two pole pieces of a magnet. One is north pole, another is south pole. So it means that this metal sheet, it is exposed to the magnetic field. So as the metal sheet here, it is passing through the magnetic field, then what happened? The magnetic flux of, the magnetic flux which is linking with this metal sheet will change. So that changing in magnetic flux will set up a current which we know as eddy current. And these current here, they are a circulating current, and they are present in the body, or we can see in the metallic body. Okay. Now look here. When this pendulum bob, it comes at the center, then what happened? you will find that the magnetic flux is maximum. So when the magnetic flux is maximum, then the current will flow in this pendulum bob in the anti-clockwise direction. As the bob is going that side towards right, what will happen? The magnetic flux which is linking with this metal sheet will start decreasing. So because of decreasing magnetic field, then the current here, which was previously in the anti-clockwise direction, now it will be in the clockwise direction. Okay, so similarly, when this bob or when this metal sheet it is coming back towards the magnetic field, then at that time you'll find the magnetic flux is maximum. So because of magnetic flux is maximum, then the current is induced, but the direction is again in the anti-clockwise direction. Alright, again when the block or when this copper sheet it is going out of the field towards left, then the magnetic flux which is linking with this metallic sheet will decrease. So because of decreasing magnetic flux, then the current will be induced in this metallic sheet, but the direction will be in the clockwise direction. Alright, so this is the first experiment which was demonstrated by Foucault in 1895. And so looking at this experiment, I can see here that when this copper sheet is oscillating in the regions of a changing magnetic field, then this current which is induced in this metal sheet will flow right in such a direction so as to oppose the motions of the oscillations of the copper sheet, right? Because according to Lenz's law, right, the induced current will have to flow in such a direction so as to oppose the motion. So when I say to oppose the motion, it means these currents here, they are circulating in the sheet in such a way that this copper sheet will stop very soon. So this oscillation here in this case, when you expose in the magnetic field, so the oscillations of this copper sheet, right, it will be highly damped. When I say highly damped, it means this oscillation will stop immediately. Okay, why? Because of Lenz's law. Okay, now another experiment which has been performed by Foucault in 1895 is instead of a solid metallic plate, he took a metallic plate with a slot. Okay, these are the slots. But to his surprise, he found that when the same copper sheet with a slot is allowed to oscillate in a magnetic field, then he finds that this metal plate with a slot, it oscillates with a longer time as compared to the previous one. So that long time of oscillation of the metal plate in this case, it is because the induced current here, right, it has to pass over a long path like this, or I can say the electrons has to travel a long path. So because of the larger paths of traveling of the electrons, then the resistance of this will be large. So because of large resistance, then the eddy current which is induced in this metal plate will be less. So what is the resistance here? Less. And what is the resistance here? R is more. Okay, so please note down. A metal plate with a slot has, this is large resistance and this is less resistance. Okay, so large resistance means current will be less. When the induced current, or I can say the eddy currents induced in this case is less, so because of less induced current, then the oscillation, right, will stop for a long time. Okay, so therefore, please remember here that a metallic plate without slot oscillate for a short time, and the same metallic plate with a slot oscillate for a longer time. So these are the two experiments which have been demonstrated by Foucault in the year 1895. So I hope this topic is clear about eddy current, and in the next video we shall talk about the undesirable effects of eddy current as well as the uses of eddy currents.